Hello, I would like to welcome you to this short presentation video of our NanoNord Tveskaeg NMR sensor. My name is Peter Larsen and I am the sales manager here at NanoNord, and I would like to introduce to you today this fantastic NMR system. The system itself comes in two versions for the food industry applications. We have what we call a benchtop, which has either the ability to be run samples through with a pump, where we have a peristaltic pump sitting on the side. We have a wet sample, we call it, and we will pump this through the system to analyze for sodium, chloride or other parameters. The other option we have for the benchtop version is actually to take a sample tube, inner tube, NMR tube. We put the sample inside the tube, insert it into the system, and then what we do with the NMR technology is send a radio wave through the sample in a given frequency to locate the sodium particles or nuclei in this case. We also have the system as an inline system, which means that we can pump any given liquid through the system and do the measurement at the same time. This measurement is what we call a flow measurement, which means that we will have near real-time results, but not real-time, as we will take some seconds or minutes to measure the given sample, so it will never be real-time, but what we call near real-time. For the given system that we have sitting here today is our system that we have implemented in a lot of snack factories all across the world. And our typical customers will do savory snacks. It can be either chips, potato chips, pretzels, batter for cookies, crackers or other food products in the savory industry. In regards to the technology of using the system, when we have the sample sitting inside, regardless if it's been pumped through or if we have inserted it in an NMR tube, the sample will sit inside of the Hall-back magnet, which is the centerpiece of the system itself. The magnet will keep all the nuclei inside the sample suspended, and when we send in a given frequency of radio wave through the sample, it will locate whatever parameter we're looking for. So that will also give us the opportunity to increase the precision by extending the measurement time. So that means that the longer we measure on the same sample, the more repetitive results we'll get and a higher precision we'll get. In our industry, we call that the standard deviation. So what we would like to do is to find for the customers a standard deviation which is appropriate with whatever product they want to measure. So for the food industry in general, we will see a measurement time of about 1 minute. The result will come up in the system itself and will be stored in the history, we call it. And it's also possible to export the results real-time, live, via the RJ45 plug on the side, or there's also the option of using a USB stick and exporting the results into this by a given menu inside the system. Now we would like to show you how we actually do a sample of the snack. And what we do is we weigh off the product itself. In this case we have a chip that is a combined corn flour, potato powder snack. And we know for a fact that we are using dilution factor 6 for this product, simply because we want to keep the sample suspended while sitting inside the system being measured. So what we do is we weigh off 40 grams of the product itself. Then we will take 200 grams of water. In this case we're using distilled water, but we also have the option of using tap water and do an offset measurement for this. So I will mix the chips and the water. I will in this case use a kitchen blender. For now, because we know this product, we're using about 10-second measurement time, and what we want to do is we want to have a good, clean, homogeneous sample where we don't have any sedimentation, we don't have any large particles inside. And this will actually give us the option to just go ahead and pump the sample right through the system. So what I'm doing now is I will put my sample down, I will take the suction hose, put it into the sample. I have the outlet side coming out of the top right here. And this one we actually normally just put into a drainage. Since we don't mix any chemicals, we don't mix any harsh elements into it, but only water inside the sample, we're actually able to just put it into the drains. So I have the sample ready now, and I will go ahead and I will choose my job. It's called chips, dilution factor 6. I will press run. It will ask me for a tag. So if I have products from line 1, 2, 3, 4, it can be the product name itself. It can be, you can write salt and vinegar, you can write salt alone, you can write ranch dressing. So for this, I will just write test, and then I press continue. We also have the option of putting in a barcode reader for the system, so we can actually just scan the barcode on the product itself. So what you see now is the sample is pumping in through the peristaltic pump in through the tubes, and is sitting suspended inside the system now. So that means that when we have the sample sitting inside the system, all the sodium nuclei are kept suspended by the magnet field. We're sending in the radio wave through the sample repeatedly, and then we will take the results and do an average of those and calculate the standard deviation and give us the result. In regards to the dilution factor of the products, you can say for most of the potato chips, we are running dilution factor of 7. For corn flour snacks, corn flour nachos, tacos, other corn flour products, we have a slightly less dilution factor, so we're running dilution factor 6 or in some cases 5. This is something that we can help a potential customer in setting. So now I will stop the system again. So now I will get the results out. I have split my result screen in two. So in the first case, I have a sodium count. So that means I can see I have 3,859 ppm of sodium inside my sample. And I will take that number, I will multiply it by 2.54 for the chemical composition of salt. Since we measure the sodium particle, we can add the chloride itself, multiply it, and I can see that I have 0.98% salt inside the product. The product in this case is labeled 1.1% salt, so we are pretty close. And by doing repetitive measurements, I can guarantee that we are a lot closer than the product declaration is in this case. In order to explain the dilution factor, I've made two samples out of the one that we have right now. So I will try and hold these up so you can see the difference. You can see that the sample right here is very, very homogeneous. It's very nice to look at. We don't have any sedimentation, and it's all kept very suspended, as we say in our field. The other sample, I have doubled the amount of water inside the sample. So you can actually see that this part right here is kept sedimentation. It goes darker and darker at the bottom, and we have free flowing water up here. This means that the dilution factor we've used in this case has been too high, and we don't want to have sedimentation sitting like this as we measure in this area right here, and we would like to have the sample homogeneous throughout. So now you've seen a little bit about the system, you've seen a little bit about sample preparation for doing snacks potato chips. Whether it be pretzels, potato chips, batter, whatever we want to measure in the food sector, in the food industry, or other parameters as well, this is the way that we do it. So we take the product itself, mix it with water if we have a dry stage product. If, however, we have products like salsa, ketchup, it can be mayonnaise, it can be a whole variety of other things from the same industry, we will actually be using the product directly. So if we have a ketchup, which is obviously in a wet stage, we can simply take the sample tubes and we will put it into the product, and we will just basically suck a sample up like this, insert it into a tube, undo the aluminum rod here, and the sample is ready to put into the system. When we insert the sample into the system, which we will cover in the next video, I will show you how to do that. For now, we would like to finish off our sodium snack sampling right here by doing a cleaning procedure. We get a lot of questions about this, and of course that's very important to cover. So now we have the sample sitting inside the system. You can see the sample in the hoses here. What we do is we simply take, you can take the sample itself, move it aside, take a glass of clean water, put the hose in, and then we go into the pump menu right here. And then we can actually do an operation of the pump. We can set it for 200 milliliters, okay? And then we say start pump. Now you can follow the clean water actually pushing out the dirty sample, you can say, or the old sample. By replacing the sample, we'll actually empty out the NMR tube inside the system and do a cleaning throughout. So you can already see now that the sample itself has been displaced, and now we just have clean water running through it. If I take the suction hose up and we keep pumping, it will actually drain out the system for water as well, and you might be able to follow it right here. We have the last of the water. So that means that the system is now clean, empty, and ready to use for the next sample. In the final step, I would like to show you how we use the system in combination with our NMR tubes, as we call them, where we can do a direct sample of your product. So in this particular case, I have different sources of, we have some mustard, we have some barbecue sauce, some ketchup, some chili ketchup, some salad dressings, some chili ketchup again, and some sweet chili sauce. For these products, we don't need to dilute these with water as they are already in a wet stage as an original product. So basically what we do is, let's say that we are talking ketchup, we will take the sample tube itself with an aluminum rod inside. We will screw this into the sample tube, like so. We will put this into the sample and simply just suck up the sample. We will add the plug to the end, like so. Undo the aluminum rod, and then we're ready with the sample. So this is how easy it is to actually do a sample for the sample tubing. In this case, right here, we have a carrier ketchup. I will insert this finished sample tube inside the system like so. I will push run, and it will start the measurement immediately. We've set this for a 30-second measurement, and we will do the sodium count, and we will do a salt. I've split the screen again like we did with the chips products. So it will give us the sodium count. We will multiply this by 2.54, and we will get it out as the salt content. Whenever we have a product, a finished product like ketchup that has a fat content below 2%, we also have the option of measuring the density of the product. Right now I'm not doing it with this product particularly because I know it already, but we can actually just set any given product into the system, and we will measure the density first because we want to know the sodium content in milligrams per liter. That means that we have a higher density than one, we need to multiply by that number to get the actual sodium count. So now I have the result for this one. I will have 5,953 ppm of sodium and a salt percentage of 1.51. So this sample tube testing is very easy, and a lot of laboratories prefer this when they are testing wet stage product. If they are testing seasoning, will be the same as we just went through before with this. They will mix seasoning and water, make sure everything is dissolved in there in a given dilution factor. In this case we use dilution factor 50 because we have a lot of salt in the seasoning. We will suck up the sample, insert the sample into the system, and we will get the result out in a very short period of time. The cleaning process for using the sample tubes is basically just reverse of what we did before when we did the sample itself. Insert the aluminum rod. We will take off the end right here. I'll try and do so you can see it, and basically just let the sample out. After this, we will have the three parts. So we will have the tube and the top plug and the bottom plug, and we will need to clean these before using the new sample. Very easy, very precise, and again, you kind of decide the precision by adding more time. If you want a higher precision, like we do with for different seasonings, we will run a 2 minute to get an ultra precision of the sodium content in the seasoning, because the seasoning is often used as setting the seasoning application rate in the factory. So that's why we need a very precise number for this. For seasoning application control process in the factories, we can see that most of our customers prefer to have the finished product is about 50%, the other 50% will pick up product at the seasoning drum, where they get the seasoning drum out or after seasoning the product, and then they will take the measurement from there. If there's any questions, if there's anything you need elaborated, you are more than welcome to contact any of the sales team here at NanoNord, and you will find more information at info@nanonord.dk. Thank you.